So we're streaming a bit early today, um, just because I'm gonna start working on something, and I guess you know you guys can see it too. Um, so started working on this program, which is a stack, and then this one, which is just for floats. Um, and so I'm gonna just continue working on this stack Armstrong program. Actually, I think I do need some special code, but okay. Yeah, I need to retrieve the program counter, and there's no instruction currently for that, so I'll make an instruction for that. Okay, so program counter, um, program counter read. Okay. Looks like PCR. That's CR WA counter read and write A. Right. Now let's go back to the stack program. And we want to have some inline assembly. counter, so that's program counter read, and I'll put it into the A register, and then we'll just write the A register into this variable. So now we'll have the program counter as a actual variable. Okay, actually, we don't need this right here. Yeah, okay, this is for use with like calls and returns. So we can save this for later. And I think we should start the stack pointer at a high value rather than a low value, and increment and, well, and instead of increment, decrement. Let's look at the memory layout. Okay. So what we have is variable and general purpose memory. Let's put it at the end of general purpose memory, so it doesn't interfere with any variables or anything. And 61439. So we'll start at like 61438. Probably good. And start this at the same number. Actually, no, it probably makes sense to start this at 0. Yeah. Now, upon pushing, what we want to do is subtract 1 from this, and then put it back into this. And then we want to take the value from the A register but the A register gets overwritten with this, most likely. Yeah, it does. Okay. So maybe we shouldn't use the A register. Let me think. The location of the stack pointer to could use a variable. And then for pop, that's, well, not that. It's stack value equal to value in there. And then just add instead of subtract. Maybe I should add, like, I don't know, what you call it, like macros or something into the language. Because right now, this doesn't really work as a go-to, because if you go to it, it'll just continue through this program. What I really wanted to do is just substitute everywhere where this is with this. So, use like something like this, and everywhere where you place this set of symbols, it then replaces it with all of this.
Four computers now have primary control of critical vehicle functions.
Gonna be- Tyler. It might not be in here. It might be in the main file. Yeah, it's in the main file. So we have this loop here, which checks for includes. So we want to do a similar thing, but for macros, I guess. Let's just get this working, I guess. What would be a good way to test this? let's assume that this area right here is a function. Okay, we'll want a pop, which is this. And then that puts it into the stack value. Yes. And then we'll need some inline assembly. Although not this in particular assembly. We want JRank. Yes, okay. Okay, so all of this right here is just the return statement. And then this is for calling, which will, let's see, read the program counter, and then push it onto the stack. So that's a call, and that's a return. Got it. Actually test this out. Actually, I could probably use this. To parse code. Well, I guess I never tried PCR, so I don't know if that's going to work as an instruction, but my progress. I am very slowly making almost no progress. Yeah. Mhm. And this doesn't really work in its current form. Because the program counter is like, when this finally gets compiled, it's way stretched up here, while the actual go-to is way down here, so there's many lines between them. Meaning when this returns, you'll just continue looping through this call. Cannot open file stack.arm. But it's right there. I don't have to do // do I? Oh, I probably do, actually. Failed to parse code. If you return to our Armstrong, first line code contains hashtag AS. Wonder why that is. Oh, wait, that's right. I didn't add the new instruction to the instruction list. There, but it's not up here. Okay, well that did assemble. And then there's this. Okay. Well, that's not supposed to be there. Another compiler error for ASM. So get down here. You know, you probably can't have this only take up one line, probably. Let's try this. Okay, now it works. 38, 46, 51, 56. Okay, so it appears to be going like this. Just between these two. The call and then the return. And this could probably work better if I put that up there. Do the program counter read, and then do that is equal to that thing. Maybe. That compiler's really bad. That's not supposed to look like that. 87,000, 33,000, 60,000. Yeah, that's not quite correct. Actually, this PCR is never even used. Doesn't fix some of the issues. Alright, so that appears to work. 70, 64, 61, 58. Okay. Unfortunately, I still have developer mode on, so I need to disable that. Alright, so it's jumping between 69, 55, 47, 70, and like 50. Okay, so I can assume JReg, or JReg, jumps back to where? Oh, it's not a static value, so that would be probably around the PCR. Which is right here. 44. So I need to find the distance between PCR and this go-to. Let's see. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Every 4 computers now have primary control of critical vehicle functions.
Oh, but then, never mind, that will change because I need to add, like, that 15, but it will be more. You know, goes into that. Right, now let's recount. PCR. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I lost it. Shoot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Alright, so we add 21 onto it as an offset. See if this works correctly. Okay, there's no blue screen, which is good. 72, 22, 78. Wait, did I say 22? And 0. That doesn't sound right. Should never go as low as 16. That doesn't make sense. Instead, what I should do is I should add A. Let's do that. Emulators main loop, you have a for loop which goes up to 16. That for loop is because each instruction has multiple steps in it, I guess you can call it. So, for example, let's see. So just for this fetch instruction, for example, in the first step, it'll execute 2 micro instructions, okay? And then it has another step where it executes 3 more micro instructions, and then there's a third step where it has a final micro instruction. And it has to do those sequentially. So there's a for loop which executes these one at a time. Well, executes each step one at a time. But all of these micro instructions execute at the same time in their own given step. If that makes sense. Four, 71, 76, 68, 66. Okay. So we're looking for like 61, 62. Wait, we need to add 1, 2, 2 onto it. Because when it returns, we don't want it to go to the function again and like keep doing that loop. We want it to start doing the next thing. So add 2 onto this, that's 23. Wow, there's 23 instructions just between those two. And then just to prove that it only executes once and then continues, I'll add something here. Loop. Loop. Go to loop and change the location. Let's see, 16382 equal to let's see, 4. So it'll display a character if it only executes once. No, I don't think it worked. Let's try writing this in hexadecimal because that might affect it. Zero x 3 FFE. No. Maybe I increased this too much. No. Maybe it's not increased enough. Oh, now the program counter's gone insane. Well, that's not good. Bring that down to 20 and then we can increase gradually. Oops. 21. Okay, right now it's on 66. Let's look for where loop is. 66. So we want to decrease this by like 1, 2, 3. So 18, I think. Yes. All right. It's working. Okay, so this is a fully functional call with a return. So now you can actually have functions, I guess, in Armstrong. That's nice. And like a bit of recursion. Give this its own example file. Really? You're already working on Armstrong? Okay. Scopes. Everything global. Well... So basically, for a variable, this variable is basically just a placeholder for a memory address. When you initialize a variable, for example, you can initialize it anywhere it's used. So the first time it's used, it's initialized. The compiler will find a place in memory where it could possibly fit in, and then it will basically replace all the instances of this variable with that location in memory. And since that location in memory is, I mean, it's general purpose, you can access it from anything. So no, there's not scopes. Everything is technically global. And the second you initialize a variable, it's like sort of permanent, I guess. There's no checking to make sure it's still in use or anything. So, yeah, every time you create a new variable, it will take up another memory address. You know, I need to sort of re-implement the includes because currently it basically just takes everything inside of this file that you include and then it pastes it right here. So if you just want to have access to a few of these, you know, like go to this label or use these variables or anything, if you just want access to those but don't want to actually run everything sequentially, you have to add a go to here and like skip over it. So before this starts executing, you have to skip over it and then just execute your own program. So I think I should just add this in to the compiler so it automatically adds a unique label. Like basically just copy this and then add it as a label. Now it's like unique and maybe a few numbers in the end. Because that's kind of annoying how you have to do that every time you just include a file. Modules. Well, yeah, you can include other files. And you can also have inline assembly. So, although you can only include Armstrong files, if the Armstrong file is, just inline assembly like this, then you can also include technically assembly as well. So hopefully that'll add a bit more use to it, since Armstrong, it really is lacking in so many places. I can't wait until Microchips releases his language. It's going to be really awesome, if he ever does. I'm not rushing him, but people are probably looking for a better way to program. Let's fix this real quick. Although he chose a syntax that I personally don't understand. It might take a bit of learning to get used to it. I'm not a huge fan of learning new languages, so yeah, might be a bit of pain to get into, but I guess it could be fun. And useful, which is probably, much more important. Why isn't this working? Yeah, I don't like Rust. That's basically it. I just don't like it. I heard it's very good, and I guess some people have created some really cool projects in it, but can't really get into it. I tried. Believe me, I tried, like, multiple times. It's very difficult, though. Stack push, stack pop. Inline assembly. Yeah, same. Ah, I see. Go-to function. There's nothing called function, it's called func. Okay. Oops. Locked it. There we go, now it works. The bad thing about languages that I always make, out of the two that I've ever made, it's not saying much, is that I don't normally have that much, checking, I guess. Like, for example, I just had, like, basically an error that couldn't tell me anything, because I just wrote function instead of func. Like, basically getting a variable name wrong totally sort of errors it out and it crashes, and it doesn't tell you why. It's not very good. that. I think it adds it on top. Oh, but the hashtag AS is already removed, I assume. No, never mind. Oh, but it is pre-processed, so maybe. Recursive descent? What's that? So we'll set this equal to CO copy. Actually, no, that wouldn't work because there is a space in that. Hi, Dorbo, welcome to stream. I think we can use path, maybe. We also probably want to include a random number. How do you get a random number in C again? Remember, we never have plans, okay? We just go with the flow, I guess. How does rand work? Oh. Yeah, C and C++. I don't know. A random number between like 9999. I don't... Does it matter if I set the seed? Okay. Well, it doesn't matter if... Well, it just matters that if it's called multiple times in the same, you know, execution, that it's different each time, which it would be, though, right? It doesn't matter if it's different between different executions. It can be the exact same. Yeah, it doesn't matter if it's the same between executions. Because it's just for differentiating things between this current execution. Oh no, this has to be a go-to, not a go to that. And then, upon that being done... Oh wait, I need to gather this random number first.
Every core computers now have primary control of critical vehicle functions.
Alright, that should work now. Now there's no longer execution of included files before their actual use. Right? Repressing. Yeah, I should probably limit that down to 1. It doesn't appear to have done anything. Let's... so you sure there's no go-to? But there should be one right there. Here's the label. But then there's no go-to. I don't know, maybe I'll just add a new line. Might be removing that line. Well, now there's a blue dot in the bottom right corner. That must mean something's different. Okay, well now there's a go-to there. And so, 35, that means it should jump to that incredibly long label. And 35. Yes, that's where that label is. Okay, good. That works. Maybe not. Why is that program counter 58,000? Oh, wait. Yeah, those variables aren't initialized. Because it's never run now. Okay. That makes things a bit more difficult. And it's working correctly, but it's not quite, just not quite as it should be. I don't know, maybe I don't want this. Yeah, I know, 30K. It's pretty big achievement. I haven't done a single subscriber special yet. It's crazy. Although with my upload schedule, you know, once I'm starting working on the 30K one, I might be at a totally different number next time. Because it'll be a year from now. I should comment about these for now. Let's see. I don't really know how floating point numbers work still. I mean, I understand how they work, but I don't understand how math between them works. Like, I don't know, addition, multiplication, etc. I hate fractions. Fractions are the worst. I don't even have signed integers. I don't even know if that can work. Well, I'm not making a floating point unit. I'm making a floating point library, I guess. Yeah, it's just something you can, like, let's say in Pong you wanted some nice floating point numbers. You can just do include float. And then there you go. You have floats all of a sudden. I mean, it's not that simple, but yeah. That's the idea. So it's all done. It'll hopefully all be done in software. I probably still have a few more things in hardware I need to change, but yeah, very pogging. And now that I implemented simple sort of functions, I think this should be able to be doable, at least in a bad form. But I don't really understand floats still. Bitwise. Okay, but that's 4 different instructions I need to add, right? And or not and XOR. Let's see, how much more space do I have? I can fit 3 more instructions. That's it. No more than that. Just 3. Until we're all out. I mean, I could probably remove some of these. Okay. Oh, but those... You see, those functions, or those instructions, they require me to make hardware. I guess I can do that. That's like... work. Oh wait, and or not. Never mind. What's... Wait, how does not work? Wouldn't that just like invert the A register? Okay, but would it not then be capable... Wait. Hold on. It's like... Because that's like 16, okay. Wait, no, 15. And then it go to 0 with 9. What's this one? 10. 5. So that's... Isn't not able to be done with, like, arithmetic operations, though? I don't know. Maybe I'm wrong. hopefully we're not running out of micro instructions anytime soon, because they have collapse set. So 10. The 2 4 5s. Okay. Okay. So 10 inverted is the same as 10 minus the max number, which is 255. And then, you know, just get rid of that sign, you know. So wait, my CPU can't handle negative numbers. Or can it? What would it do with that? I guess I can see some stuff. Wait, I have no way of viewing this value. Never mind. Whatever. I guess I can do this. It's not a huge deal. Alright, so we have shift left, shift right, and 9. And we'll also add these up here. Wait, the ALU. 3-bit. So that's this is 3-bit, so there's space for 2 more. Seriously? Wait, no, there's space for one more. There's space for only one more. That's annoying. Although I could count it as a read instruction. Wait, this one's also 3-bit. Time to make the ALU instruction 4-bit. 16 large. No, why do you keep adding a space? To 0. Oh. 0 went on the wrong side. Stop doing a space. Ah. 0. And 0. And not. Generate the microcode. Change this as well. Parser. See if it still works. I think that's everything I need to change, but maybe not. And it is! Nice. Okay, so that's 3 more instructions. Well, I still need to actually implement them. Oh, I didn't add them here. Never mind. Do it the way. It's 110. ALU underscore. What were they? And or not. Now let's see if it still works. Such that like the big ones. Alright. Now we need to implement them in the emulator. A register and B register. You know, implementing this in the emulator is way easier than implementing it in actual hardware. It's gonna be a pain then. Wait, how do you do? Hold on, I'm a noob. Bitwise not. Oh, it uses the tilde? Alright. Sure. Or not? Okay. Oh. Alright, that should be it. There's no instructions at its max. Can't go any higher. I don't think, right? Yeah, 5-bit. Okay. Or not. I really don't have a way to display the output though, like of a number, other than like pixel values, I guess. You know, maybe what I should work on, maybe next, maybe not, I don't know, is a library or Armstrong file, whatever you wish to call it, or just displaying simple text. Stay hydrated. How do you reference a branch?
Liftoff of mission 41B, the first flight of the orbital Discovery, and the shuttle has cleared the tower. Discovery's 4 computers now have primary control of critical vehicle functions.
Well, whatever. One issue done.
That's one small step for man, one giant leap for mankind.
I'm getting kind of sick of this music. Let's find something else. I guess I can try inverting the colors of this image. I'm surprised this code still works. It's like one of the first programs I made in Armstrong. I guess that kind of shows that I haven't changed anything really. Come on, just work. I hate the quotes in Visual Studio Code. They like add too many, and they're dumb. Let's see. No. And then change that to A. See if it works. Just invert the image. Wow, that is not correct at all. what is causing that issue? Wait, was this working? This wasn't working. Why was this not working? Oh. Hmm. That's not good. I have no idea why it's not working now. When did it stop working? Does Pong still work? No. Hmm. It's not good. Let's revert the changes. See if that fixes anything. No. When did this issue get here? Oh no. Isn't this the same result I got on hardware? crashes. Okay. I think I might know why it crashes. I don't know if that'll fix it. And it does fix it. But I just removed all my changes, so I don't really know what exactly fixed it. Nope, not yet. Well, I basically just reverted all of the changes that I did, and I'm gonna do it again. Make sure I don't mess up this time, I guess. Yeah, I'm adding bitwise instructions. Well, I did have them, but then the emulator broke, so I'm re-adding them technically. Shift left, shift right. See if there's any errors. Well, yeah, there is. Oh, that's right. Crashes. Okay. Still crashes. Yeah, Gerard, you know, that's why my language is obviously the absolute best, because it does things the old-fashioned way, you know, no optimization, none, 0% optimized code, just how it was meant to be. The absolute best, that's right. Yeah, if you're not optimizing your own code, then you can't even call yourself a programmer, alright? You better be out there, you know, not even writing in Armstrong, just like, you know, inline assembly all the way, right? Just write your programs like this, you know, make sure that everything is just as it was meant to be, you know, every single line is tailor-made for your program. That's the true Armstrong experience. There we go. And crash. Okay. That's fun. Still not working. That is great. Perfectly fine. Totally okay. Size is correct. I don't know why it's not working. Well, it's still not working, but at least it's displaying something this time and not crashing. Well, that's the same thing it displayed before, so we hadn't made any progress. That's not the correct spot. Mm-hmm. 0, 1, 2, 4. That's the numbers. Yeah, that's correct. Now it's working. Because I was counting to 4 incorrectly. That's frustrating. Guess I better, go back to the first grade. Learn how to count again. And now it works. And... okay. I can implement the rest of these. And or not. I also did counter 3. Oh wait, no, that's just an instruction. What was this instruction? Float. No, function. PCR, or program can repeat. Yes, the counter instruction is coming back. When you said you didn't need it, I was a bit confused because I did realize, like, the function it could serve. And yes, I discovered that I needed it when I was working on implementing functions. So now that functions are in, this is required to get the current position. Well, it's not technically required, but I mean, who wants to compile their program and then look at the actual number that they get, I mean, just compile this, look at the number, go back here, put it in, see if it works. Nobody wants to do that. So this just basically automatically gets the number. You also have to add an offset, though, if you want to use go-tos and stuff. So I do that there also. But yeah, this was already implemented, but I had to remove it. storing the index of the variable? What do you mean? Wait, like you're hard coding the index of the variable? That's just... It's not very scalable. Come on. Do better than that. WA. Wait, no. Add? No, it's and. Function. Drip. Pointer to the function is in the program. Yeah, but like hard coded in. I just. No. No. Okay, well, once you get program counter read, just fix it. Make it better. Wait, are you making your own language? Do you have a separate repo for that? Same? Oh, really? Okay. Let me look then. I mean, I guess you can do that, but what is this? Yabble? Is that what it's called? Do you have any example code? Where? Tests. What? It's in. Come on. You gotta separate it, you know? It's like C. Another one that's gonna be like C. Microchips, well, I mean, he says it's like C, but it looks more like Rust. Well, I just can't wait until there's more functionality, because, yeah, this is not probably viable here. And what you guys are doing is really cool. Like, you might be able to make some pretty cool things with the languages you're making. Especially if it's optimized, because larger programs are a lot more difficult to make if they're not optimized, because they'll slow down the system a lot. What post? In Discord? Oh. What? Sorry for the yell. How? How did you do that so easily? Does that compile to the same assembly as or his function calls or seems yes seems. Does that compile to this assembly, these instructions? Because if so, I'd really like to, I don't know, have a compiler for that and be able to use it with this emulator. It compiles to the exact same ones. So like assembly that's output from your compiler would just be able to be used in this right away with no changes. I mean, not this one exactly. This is the dev branch, so there are a few changes. A hex file writer. Oh, well, that isn't that difficult. I mean, mine just... Okay, the bytecode's the same. Oh yeah, speaking of, this emulator can't read that yet. It should be able to read an already assembled, you know, bytecode file, I guess, but it can't. It only can read assembly files and Armstrong files, and then do the assembling and stuff afterwards. That probably should have been, you know, a feature, but it's not yet. I'll work on that after this. It's really simple, because all I have to do is load that into memory. But Gerard, it would be really cool if you could make your emulator and your compiler separate. You don't have to, but it'd be really cool, because that way you could, you know, download the compile programs, and then use it in any emulator. Compiler to assembly? Yeah, you could do that. Well, basically, actually, okay, so what Armstrong does, or the Armstrong compiler, it'll compile it, and then it outputs all of this assembly text. This is literally just all of the assembly of what it's been turned into, and it doesn't save this to a file actually, but I think that was like the original purpose that I was gonna do. There's even comments saying what each of these was, like change that to that. That's just this command in the Armstrong. Yeah, so that's another thing I should work on. Yeah, it would be cool if you could make it like a separate program, and you don't have to just link to it inside of your emulator repo. I'll put it in this other project relating to the Astro-8. I hope to put like everybody's language that they're working on in here, and that way, you know, there's sort of like an ecosystem of languages you can choose from, you know, with pros and cons, that, you know, you don't just have to use assembly or Armstrong, because those aren't the best. I need to finish this. I mean, all right, connected. just like disconnected for a second there. I don't really know why that happened. No, it was mine. Well, I didn't disconnect from the internet. Like, I think it was just OBS freaking out for some reason. What are you working on now, Lucas? Well, there's probably going to be a few days until I actually release this on the main branch. Because there's quite a few changes, I guess. So, yeah, I don't know, it might be a little bit. BM stuff. You're gonna make your own language for the Astro-8? Really? Okay. I mean, you can. We're gonna have as many languages as Windows, you know? Basically the same, though, right? Oh, we don't have an operating system yet. Oh wait, we're waiting for microchips to do that. He said he wanted to do it using his language, which should be really capable. Alright, BSL, BSR. And or not. You know, speaking of competition, well, at least one or two languages are actually complete and, you know, easy enough to use. Easy is probably not a good term, but easy enough, you know. Then I think I might actually host, like, an itch.io competition or something for making, well, like a jam for making maybe games, maybe programs just for the Astro-8. Because that could be really cool, just like seeing all the cool things the community can make for the processor. Currently, the number of programs is limited to basically the few that I made, like Pong and the typing one, and well, there's Snake and the platformer. I'm not sure if any progress has been completed on those so far, but they're at least really cool demos right now. No, Gerard, don't hurry, because we're gonna wait as long as required, because if there's a bug in the language or something, you know, I don't want it to be like my fault or someone else's fault for someone not being able to participate in the jam just because well, the actual system's not working instead of just them or their code. Alright, good. Rainbow now works. And now we'll see if inverted rainbow works. So that will be not. No, I guess. Not really. Maybe I should bring this down here. I don't know, there might be some more processing going on that I'm not aware of. I think that broke it more. Huh. Wait, you're gonna have objects? How are you doing all of this? You people, I don't understand. I just don't. Oh wait, that's why not's not working. Because I didn't actually implement it in the language yet. Or in the emulator. Scroll down to here. Yeah. A heap? You know, I haven't done too much research on other systems, like, of the time, what am I talking about? Like, of the same type, like, in the 80s and stuff, you know, like, there's the Commodore 64, there's the ZX Spectrum, things like that. They were probably just about as limited as this. Not talking about the resolution. 64 by 64 is abysmal, but that's definitely going to be upgraded. That was only temporary anyway. But, like, I think the Astro-8 sort of, like, is almost as good as one of those, right? But I'm just not sure what was the standard of those times, because, like, programming and stuff has, well, there's been so many more advancements since since those came out. And also people have been asking for a lot more, like, making a lot more demanding programs. So, I don't know, like, how far I should really go with this. Register. Eco 80. Wait, what's the Pico 8? Hold on. Oh, that. But that's like a game engine. Also, isn't Pico 8 128 by 128? Yeah, it's 128 by 128. Also, it's only 16 colors. I have many more colors than that. I have... Wait, how do you calculate number of colors? I have... 5. Wait, is it 5 to the power of 3? I have like 125 colors. That doesn't sound right. I think I have more than that. It'd be cool if you allowed ROM loading for your emulator. What do you mean by ROM loading, like loading in already assembled programs. Because I was already planning on doing that along with well, yeah, like ROM loading. Although I wouldn't call it quite ROM loading, it's just like, I don't know, a faster way to load in for the emulator, because the hardware is going to be different than that. It's going to have its own way to load in programs, because you obviously can't just drag and drop things. I think one way to do it would be to have like an interface with my actual PC, with like USB or something, because I plan on having a USB controller in the Astro-8 build. So that could be a possible way to load programs, but it also doesn't have like a BIOS, so I'm gonna have to probably make one of those for booting into like an operating system, because otherwise it can't do anything, because it needs an operating system in order to load off of USB. Yeah, the hardware is going to be a lot more complex than the emulator. Oh, I'm dreading it. One one 110 111 100. Scroll down. You and do a or. Not. And not is this. Okay, let's see if it works now. Did that actually invert? Let's delete this. Open up another one of these. Whoa! It actually did it. It actually inverted. Nice. Okay, so then not... Well, like, all the logic works now. Because, I mean, assuming. Wait, is that actually inverted? It just looks flipped, honestly. And maybe a bit lighter, I guess. Oh yeah, because I do add sort of a darkening to it, so it looks better. And there goes your headset. I am so sorry. That's why wired is better. I mean, not really, no. Although, if you have like a 10-foot cord like I do, wired is not as bad, you know, as it normally is. Alright, commit these changes, I guess. bitwise operations. What else did I do? Okay. All right, I'm gonna take like a 2-minute break. I'll be right back. Alrighty, I'm back. Just food. Alright, Gerard, I'm gonna try out your compiler. Wait, how do you use it? Are there like directions? Well, it depends. You see, people can use your VM, but most people are going to be using the, like, official one. So, if it doesn't, you know, work, then not many people are going to be able to, like, try it out. And if they're, like, even if there are directions telling you that it'll only work in yours, then, I don't know, it's still less likely that people are going to do it because they're going to have to download more things. It's better if your language can just be, you know, compiled for the main branch. Or your language can be compiled for the main branch. Because that's what most people are going to be on. Also, that's what the hardware is going to be based on later. So... Let's see if Logisim now works, because I think that issue might have actually been caused by the compiler instead of Logisim circuit itself. I mean, it's a totally different binary value. So maybe. Alright, let's see. Simulate, reset, play. No, it doesn't seem to be working. Maybe if I revert all the changes? No, I better not.
That's that sweet refrain all night long. An everlasting melody for melody for.
Makes no sense. Hold it tight. That makes no sense. One. Okay, now characters work. That's good. You know, it'd be cool if someone was able to render the Mandelbrot set. Just, I know, kind of random, but Mandelbrot set, that would look really cool on this. Especially if it zoomed, that would be great. That could be a goal for someone, I guess, during the jam. Okay, you wanna post that assembly code? I'm a bit rusty because I've only been using Armstrong for quite a while. But I'll try to help. You can post in the Discord, I guess. Okay, so it's only in that one pixel there. Hey Gerard, welcome back. Okay, let's see what the issue is. LDW here, 6554, store large. Okay, so that stores white inside of 16529. Right? Sorry, what does store large do again? Let's go to the documentation. Also, I probably shouldn't have to say this, but are you using the most up-to-date version? Because there might be some changes. I don't know. It's been like a week since those since the version was updated, but still. Stores B into address of A. No, that was store A out, STAOUT. This one uses the value directly after it as the address to store A into there. So it stores A into that address. So it would store, okay, so it loads white into A because 65534 is white, I think. And then it stores it into here, which is the first pixel, I think. Top left. Let's see. Memory layout. Wait. 61439. That's 16529. That's general purpose memory. Oh, wait, so are you storing that as like a variable? Okay, so this does not write to the screen. This sort of writes it as a variable. Alright, so let's write some like pseudocode. This variable is equal to 65534. 61439. 61439, that's the first pixel in video memory. And it stores that in 16539. Okay, so that's like pix offset. Because that's also in general purpose memory. Okay, then load large. What does that do? Directly after instructions address. Okay, so it loads from there into A. Got it. So it'll load 16529 into A and then swap. So it would be E equals B. Okay, well, Lucas, first of all, well, you jump to address 3. You know, I'm just looking down. Address 3, 0, 1, 2, 3, that is 16529, which is probably some sort of random instruction, because it won't skip over this. It will think that this is an instruction because you purposely jumped there. I think you want to jump to, like, I don't know, 0 or maybe 4 or something, but right now you're jumping to this value, which in its binary form could be any instruction. So let's try it as like 0, I guess. I mean, it's still not working. No. Yes? No. Can you see this? It disconnected again, so I don't know why. It's like the second time. Alright, I'll keep trying to figure this out. You need to comment it. It's difficult to understand without comments. Alright, load large. Here is 16539. So that loads in pix offset. Store A out. Let me look, see what that does again. Store A out. There's A as a memory address. And then put, okay, so you put B into A, basically. So B right now is equal to this. It's equal to V, which is white. I should rename this white. Okay, load large, so it loads pix offset into A. Okay, so I see what it's doing. Pix offset is equal to white. Well, not pix offset, but pix offset as a pointer is equal to white. Because you load that into A, and then you store B into A. Well, into A as an address. Load immediate B 1. Load large 16539. What does load large do? Directly after instruction is address. Okay, so that um 16539. It's pixel offset. Well, you're resetting pixel offset each time. Like, this increment by 1 isn't going to do anything because you reset it when you jump back to the top. So 0, 1, 2, 3, 4, 5, 6, 7, 8. You want to go to 8, I think. Oops. I just started something. There we go. Close that. See, there we go. Now it's white. It's because you were resetting this every single time because you were reiterating over it. So adding 1 didn't do anything. Yeah, no problem. Yeah, that's why you know, like it makes it look much better to have the numbers on the same line as the related instruction, but because those numbers are actually taking up a spot in memory, it just makes more sense, at least in my opinion, to make it obvious that those are taking up like their own spot in memory. Um, so you just like count them as a line. It's possible to do something like this, right? Or do you have to comma separate it? Oh, so you can. Okay. Haha.
too soft. That's that sweet refrain all night long, and everlasting.
Hey, what's up, Dora? I'm working on some, well, just like handling arguments. Like you can tell it to compile or assemble, or I'm gonna work on, like you're able to compile and assemble it into actual bytecode and store it in a file, so it's actually possible to, you know, send programs to people and stuff and not have to have them compile it themselves, even though it's like just as easy, but whatever. But that'll make it possible for other programming languages to be used, because they can just package it into one file. fixed it. should now save as a .aexe file. Let's see. Right. Looks good to me. Let's probably use new lines instead of spaces. It's kind of ridiculous. Also, the hexadecimal value would probably take up much less space than an int. Alright, we just passed 5 hours. Nice. I guess I should open up terminal to actually test this out. I've never used this by terminal before yet, so I guess this would be the first test. Even though, you know, has supported it for a while. And then go to Astro-8 emulator. Actually, let's go up and put this in the release folder. The third time that it's disconnected. 3 times, OBS. Why? Why do you keep disconnecting? It's not my Wi-Fi. I'm not disconnecting from Wi-Fi, right? I don't know, maybe it's very quick disconnection, then it reconnects, so I don't even notice. Still, ridiculous. OBS wants to have a break. Well, doesn't deserve a break. Wait, weekend? It's not the weekend yet. It's only Friday. Speaking lies. Okay, so for some reason that didn't work. Volunteers. Yeah, I woke up anybody. You can do anything you want. I have accepted quite a few pull requests already, but not that many people have actually been like, you know, helping. It's mainly been the same few people. Like, Luigi. Not the one from Mario, though. The one on the server. He's done, like, a ton of work. He's awesome. Okay, so for some reason that didn't work. Alright, thanks. I can always use the help, really, because I'm basically like the only person working on this kind of full time, so. Oh wait, I didn't compile this, did I? Yeah, you probably have to compile before you actually use it. Nope, it still doesn't work. That's fine. That's why. Now let's try it. What? Oh. Oh, yeah, I need to update it, which I need to move to this folder, then go to this folder. You can't see this, but I'm like totally going through every folder. Alright, now let's try. There we go. Now command line works. I mean, it was working before, so I must have broken something. But now let's try it with arguments. So now there's a new file called out.aexe. Also known as Astro-8. You know, it's like an exe file, but for this processor. So that should be made for the Pong program. And hey Hezzy, welcome to the stream. Let's try loading this program in. So that's a totally compiled bytecode version. So that would be .out.aexe, and we'll do this run. Okay, it's doing something. I don't know if it's doing it correctly, but ah, man, wasn't correct. So disappointing. Alright, let's try that again and see what the actual output was. Nope. Okay, I didn't stop it fast enough. L. What? Scroll up. Oh, that's it. That's okay. It just shows all of this, and it's not even loading it incorrectly. That's weird. What? Because the AEXE should not be empty. Oh, it is empty. Okay, never mind. So it's loading it correctly, I guess. Okay. So it's 333 right now. Okay. This updated. Okay, now it's definitely not empty. There's definitely data in here. So now if we try loading that in, it definitely got some data. But was that file like overwritten or something? It might have been overwritten. Or it might be getting overwritten. So let's just run it again, let it go fully. Also, I don't know why this is printing out. I don't think this should be printing out right now. Alright. Start up the directory again. Yes, okay, so it's getting overwritten whenever it runs. Even if it's loading that program in, it overwrites, you know, said program. So, recompile. So it's just loading in correctly, I guess. Path to file. It should probably be trimmed. I don't know if it'll have much of an effect on it, but it should be anyway. So instead of else, that should be else if. Nice. What do you plan to major in college? I mean, probably CS, right? I don't know. Could be something else. Yeah, computer science. Are you going to take any other interesting classes? I don't know, like... Could be CE. What's CE? Engineering? Or... Ah, okay, yeah, that's what I thought. What's that related to? Like CPU design and stuff? Sort of what it sounds like. Oh, okay. Yeah, that makes sense. The ethics of coding? What's that about? I've heard of like the ethics of AI and I don't know, things like that, but I don't know. I've heard ethics of coding. Oh, okay. More general. Okay. Hey, Callahan. Welcome to the stream. many people do we have now? I don't know. YouTube's telling me there's only 2 people here, but I think there's more than that. Hexadecimal to decimal. So it should be working. I'm not sure why it's not. Memory bytes. I don't think I ever closed this. If not close. Oh wait, I don't want to run it like that. I can prove that my internet is not going out. Okay, it's like the Wi-Fi symbol. It doesn't go away. I don't know why this is happening. And I have very good internet, so it shouldn't be happening. It's got to be OBS. Yeah, big L. Alright, let's compile this program. There we go. Now the AEXE file. This data. This music is kind of loud. Alright, the AEXE file has data in it. Now we'll try and run that data. Okay, why is it still printing this? That's weird. It even overwrote it again. Alright, compile. And instead of using --run, we'll just do -r. See if that works. No. It just seems so because it's still printing this thing. No. Okay. Huh. Command find. Oh, you mean Control F. We don't use Macs here. The print? Yeah, so the only thing that could cause that printing is this right here, color and print assembly. And there's only 2 instances of it in the entire thing. So let's see why that would ever, you know, not work. First, let's see if these are, because -r --run. Yeah, that should match. Maybe I can remove the else if. Is there anything that calls those functions? What do you mean? Like they're called right here. But I have checked against run Astro executable for both of them. So if that is true, then those should not ever execute. I don't know, let's look in other files, I guess. I don't think it's in any other... Oh, wait, never mind. Wait, that's just the definition. Yeah, no, so these are the only two locations of it. Meaning, I think this is not working correctly. Let's just like print all of these out. Because it might not be getting this argument correctly. I think that's like one of the only ways this could not work. Yeah, that's what I'm doing now. Trying to see that. Let's see. I don't know where I'm supposed to be looking for these. Well, you see, I'm very used to having bugs in my code, so yeah. I just naturally start debugging without even realizing. These aren't even printed anywhere. Maybe if I doesn't ink. I'm not used to printing in C++. Oh wait, I'm dumb. This is like the 10th time I have forgotten to copy the executable over to the location that I'm currently in. That would be release. Alright, now let's try it. Okay, X that out. Alright, 0, 0, 0. That's what they are right now. Now we'll try with -R. Stop that early. Okay, so it's not getting that -R. Yeah, because that should be the third one of these. It should be 1, not 0. So that's the issue that we're having. Yes, very brilliant. I mean, it would be more brilliant if this didn't exist. But this all code has to have problems eventually. Nope, still not working. Let's see. Okay, let's execute this. Stop it. Up. Nope. Still not working. That is very weird. Overriding it? Well, there couldn't be because there's nothing between this and here. Like, this is where it prints out the values, and this is where it sets the values. To happen first? But why? What? Well, I can use else if, because that's how it should be, but then I like changed it. It's gonna be some really dumb reason that I don't even realize. Let's run that, and it didn't work again. Yeah, 0, 0, 0. let's try that. Now run this. Oh, it worked! It worked! Okay. I trimmed it. All I did was remove white space on both sides, but why would there be white space on sides of an argument? I thought that there wasn't any. Because, like, why would this space be included in this? Unless it counts as the enter when I hit enter like that. Okay, so now we have, exe programs, or AEXE programs for the compiler, or the emulator. Okay, so that should make it easier for people who are making their own programming languages to package it into a file that anybody can use and any emulator can use. Getting kind of sick of this music too. It's always so satisfying when you get a bunch of work done and you do the commit and then you just push the push button. It's great. Then all of your changes are saved. Are you like going around picking locks? So this should make the jam a bit easier. That way we don't have to share code with each other. Alright, we're almost at 6 hours of streaming. Wow, that's a long time. I think I'm done. I'm about done. Thank you everyone for watching. Got a bunch of work done today. I'll probably stream again tomorrow. And for that game jam that I joined and was like maybe halfway done making a game for, I think I gave up on that. There's still 2 days left of it, but it's kind of boring. Alright, goodbye everyone. I'll see you again tomorrow.